I just wanted to provide a small voiceover before the video starts. Please enjoy the video. However, I do believe that it needs better credibility. So, I will be redoing this video in the next few weeks. Please enjoy.
Baker back. I know I'm not wearing a hat. It's sitting right over there. Okay, this video is big. When I say big, I mean it'll blow your mind. I am going to say I'm sorry right off the bat. I will have to go back and forth from the information I have at hand. So every once in a while you might see me look down to the side. As I've got my computer right here. If I had my setup the way I wanted it, it'd be right above it. That way you really couldn't tell the difference, but I'm going to be honest with you. I got asked a really big question. And I'm going to go over this question. And I will go back and forth on the computer to get the exact names and locations because I can't remember all this. Question I was asked by a old coworker and I'd say at least a friend, an acquaintance. The question I was asked, what is dark matter? And dark matter is a very, very good question, and I love it that I got asked this. But dark matter is also broken into two different categories. There's dark matter and then there's dark energy. Just like we have regular matter and regular energy. Dark matter and matter work differently. Regular matter works with lights, and I'm going to read a little thing word for word so I can remember. Okay, now I remember. Sorry. First and foremost, dark matter makes up 80% of our universe, and I actually found out that there was a university that discovered a galaxy that was 99.99 or 98% dark matter. That was all of it. It was just 0.01% regular matter. Dark matter, dark energy, do not emit light or absorb light. Like regular matter, which is everything, including ourselves and everything around us, from my remote to that pad of paper. It emits light. That's why we can see it so clearly. It's not hidden. But dark matter is the opposite. Dark matter does not emit or absorb light. It's pretty much pitch black. And there is nothing that we have here on Earth that can actually observe dark matter. And scientists can only prophesize that dark matter actually exists. Since we do not only or possess the technology to actually find it. So, sorry. Something's stuck in my throat. My remote's not working and it's aggravating me. Why don't you work? It might work if I press the right button. That way you can get a little closer to me. That should be good enough. Alright. Okay. So, does dark matter exist? According to science, it does. And the only reason why they can discover it is when you are looking at like planet rotations. The farther you are away from gravity, it's hypothesized it should spin much, much slower. Just like when you're going, like say, even though we can't, the speed of light, time slows down. However, as they've looked at parts of the Milky Way galaxy, and a galaxy that is similar to the Milky Way galaxy in size and all, but between our galaxy and their galaxy, our galaxy is only made up 80%, whereas 20% is regular matter. The other galaxy, which I will talk about, is called the Dragonfly 44. it only has 0.01% regular matter. And it took a telescope in Hanamea, I believe, which that exact things right there, what is on my computer right now is, it tells me the researcher, and it was at Yale University, and his name is Pieter van Dokkum. Pieter van Dokkum, or Dokkum. And if I mispronounce his name, I'm sorry. It does have a heavy accent in the name, so it's a little bit harder to tell. And I misspoke. Our entire universe is 80%, not here. It's a little bit more far-fetched. But in Hanamea, Hawaii, or Hanamea, Hawaii, however you wish to pronounce it, they use a telescope with, I believe, 4 different lenses, and I will put all my links in the description below where I found all my information from. It took 4 different lenses, and as they looked through it, they noticed that instead of it slowing down, the gravitational pull and the stars' movement slowing down, they were actually going faster and speeding up. And the only possible solution was it didn't have regular matter, it only had dark matter because they couldn't see it. Because matter is what helps speed up the flow. So they always believed that in time, everything would eventually slow down, because when the Big Bang happened, they just thought it was all burst, but it wasn't exactly. Dark matter slowly helped pulling it all apart, which has helped shape and stretch out our universe. Sorry. At the same time, due to this, the energy is not dissipating, so it is still speeding up every single day. So the universe is growing at a more rapid rate than it does. So every day it's expanding more and it's growing more than we'll be able to see it. Hopefully, sorry. Like I said, if you see my eyes hard, it's because I'm double checking information. Because, like I said, it's really hard to remember all this. I mean, this is a really great topic, and I'm so happy I got the opportunity to look at all this. I mean, this is incredible. I don't know what else to compare to this. The Galaxy Dragonfly 44, it said it was first detected in 2015, and it was used by the Dragonfly telephoto array in New Mexico with a combination of 8 telephoto lenses and cameras. But the team that found it went to the Gemini University, also in Mauna Kea, like I said, to make new photos using the Gemini multi-object spectrometer. They created a color image of the galaxy, which I will show a picture right about, I always try to have trouble figuring out where I need to match. Right about here will be a picture, or from this point on through the rest of the video, of that galaxy, and I'll do 2 different ones. One will have an extra arrow pointing for after the other picture disappears. That way you can actually see it, and they are pretty much saying it's like just a dirty smudge because it's really hard to tell. There's not much light emitting from it. That's why it's so fascinating that it's as large as our own galaxy. I mean, could you imagine just the thought around that? Our galaxy is the Milky Way galaxy, and this one is how many light years away? I don't think I ever found that, or I did, and it was hard to pick up. And I know I'm staring at my computer. I'm sorry, there's just... It is 70,000 light years away. Sorry, it took me a little bit to scroll back up. Like I said, I hate going from camera to computer to camera to computer. I really do apologize. And I'm gonna try to stay off the computer now and just talk about what all I've learned. But the difference between the two, regular matter, baric, it's a hard word, and it starts with a letter B, and it's hard to remember, and I hate that I can't pronounce it. Baryonic. It's Baryonic, and I hate when I mispronounce words. And regular matter is baryonic, and that's how it works and emits and absorbs light, whereas dark matter is non-baryonic. It doesn't. It pretty much shrouds it. I guess the best thing to imagine, in my opinion, would be pitch black and trying to shine a flashlight in it, but the darkness literally, it can't absorb the light, so it pretty much just blocks it. It just conceals it, so there's no way to see it actually there. And I mean, that's just fascinating. And I really do that. I hate to keep going back. This topic is just so large. So I'm going to read a small passage, and then I'll come back and talk about it. It says, and I quote, "Most scientists think that dark matter is composed of non-baryonic matter. The lead candidate, WIMPs, acronym for weakly interactive massive particles, have 10 to 100 times the mass of a protein, but their weak interactions with normal matter make them difficult to detect. Neutralinos, massive hypothetical particles heavier and slower than neutrinos, are the foremost candidate, though they have yet to be spotted. A river of neutrinos streams from the sun, but because they rarely interact with normal matter, they pass through the Earth and its inhabitants. There are 3 types of neutrinos." And then a fourth, the sterile neutrino, is proposed as dark matter candidate. The sterile neutrino will only interact with regular matter through gravity. So since regular matter can work with everything excluding ourselves, the planet, the stars, the universe, the galaxy, however you wish to look at it, it is a force acting with us and a part of us, whereas dark matter can't. The only thing dark matter can do with regular matter is through gravity. That's the only way it can interact with regular matter is through gravity. That's the only possible way. So, hence the reason why they've stated why dark matter makes it so much the universe. Because right here on Earth, we don't feel like we're moving really, but the Earth, we all know, rotates. It spins. And in space, it spins much, much faster than what it does here on Earth. We have gravity to hold us down. And that's how dark matter plays into that. Even though the gravity dissipates as you're leaving the atmosphere of the planet or the star, however you want to look at it, that's where dark matter comes into place. That's what helps keeps the rotation. Because without that, the energy would just dissipate and it'd be pretty much like a standstill. Nothing could move, nothing could work around itself. So, that is amazing. And I really, really hope that even though I can't give it the best information possible, I can definitely link this, and I will probably come back to this. I would like to do a redemption video on this because, in fact, I should have memorized this a little bit better, and I just got this question just the other day, literally, because I try to get my stuff done before Friday or Saturday. I try to upload, well, not upload, I try to record and work on them the day before. So I just got asked this question literally not even 24 hours ago. So I have not had as much time to prepare as I have on some other videos. And I was asked a lot more questions, and I can answer them a little bit more easier because they're kind of, I wouldn't say personal, but you could label them as personal because it's like your own opinion from it. So I would like to apologize on behalf of the people that discovered dark matter. I will redo another video on dark matter. In my opinion, I need to, because I am not. I'm happy that I'm able to give a little bit of inside knowledge, but I'm dissatisfied that I'm jumping back and forth. It bothers me. And I will still upload this video, which you won't know any of me saying that till now, 15 minutes in. But I would love to redo this, and I would love to do it in a manner where I can actually focus on you guys, the fans, instead of having to go back and forth, because to me that's just, it's not really I'm trying to think of the right word. I think the best word for it would be discreditable, I guess, because I'm not giving enough credit to the people, because I could not give enough power and energy into this one. And I would love to. I love science growing up. I still do to this day. At one point, I really wanted to actually work at NASA when I was younger. So I have always been fascinated by stuff about this. But if I can, I will try to redo this video and give it the proper video it needs, the proper video to provide the best information. So, if possible, I will try to do this video for Tuesday, and I will make sure that I'm not going from here to there to here to there to the other, back and forth. So I will see you in the next video.